Okay, Year 11 Higher Session 4. This is for your final paper, which you'll be sitting Friday, the 30th of April. And again, I've got all of the Hegarty numbers here for you. You should have this document with all of the Hegarty numbers. Blue topics are essential if you're aiming for a grade 4, green if you're aiming for a grade 7, and then the orange ones to achieve that highest grade 9. So going through the questions, please. We're starting with the area of a rectangle. So work out the area of a rectangle. Oh no, I think I've missed one. There we go. As an estimation, we're told that 5 miles is 8 kilometers. So 5 miles is 8 kilometers. I always like to write the thing we know here as an equivalence. 5 miles is 8 kilometers. Convert 27.4 miles to kilometers. So if you want to know what a conversion is, you can always do big divided by small. So 8 divided by 5, which is 1.6. So that means I know that to go from miles to kilometers, we need to times by 1.6. And to go from kilometers back to miles, we need to divide by 1.6. That then helps us with our question. We want to convert 27.4 miles into kilometers. And since we're going from miles to kilometers, we're going to do 27.4 times by 1.6, which is 43.84. So that's 27.4 times by 1.6, 43.84 kilometers. So 27.4 miles is about 43.84 kilometers. Cool. Question 2, work out the area of a rectangle. So all of you should know how to work out the area of a rectangle, but just to recap, the area of a rectangle is base times height. So if they've told me the base here is 7.9, let's just label that on. And they've told me that the height is 3, we're going to do 7.9 times by 3. And don't forget, this is a calculator paper. So we can use our calculator, and we've got 23.7, and this is going to be millimeters squared. It's an area, so millimeters squared. Cool. Work out 1.8 times 10 to the power of 6 divided by 6 times 10 to the power of 2. So when we've got two numbers in standard form, we could say, right, 1.8 times 10 to the power of 6, we know that's going to be 1,800,000 divided by 6 times 10 squared, which is 600. So we could do it like this. There's going to be a much easier way to do it, and that's going to be to keep it in standard form. We know that the digits aren't going to change, so we're going to do 1.8 divided by 6. Now, if you want, you can use your bus stop method or use a calculator. 1.8 divided by 6 is 0.3. And then we know that when we have 10 to the power of 6 divided by 10 to the power of 2, we subtract the powers. So when we're dividing, we take away the powers. So 6 take away 2 is 4. So my answer is 0.3 times 10 to the power of 4. However, I'm not going to get full marks for this because it's not currently in standard form. Remember, standard form needs to be a number between 1 and 10 times by 10 to the power of something. So this number isn't between 1 and 10, so we need to make it 3. Now, if you've made this bit 10 times bigger, then you need to make this bit 10 times smaller to keep the number the same overall. So this becomes 3, and this becomes 10 to the power of 3. We're timesing by 1 less 3. We've almost nicked it to go into that first bit there. So that would be my final answer, 3 times 10 to the power of 3. Okay, the next one is timesing. So exactly the same, but we're timesing here. So we're going to do the same method. 3 times 5 is 15. Times 10 to the power of, well, we've got 7 here. And because we're timesing, we're adding the powers. But when you add a negative, it's going to subtract. So 7 add minus 4 is 3. However, again, this isn't in standard form. 15 times 10 to the power of 3 needs to be 1.5. because that's between 1 and 10. And if we've made this bit 10 times smaller, we need to make this bit 10 times bigger. So if we've divided this bit by 10, we're going to times this bit by 10. So times 10 to the power of 4. And that would be my final answer, 1.5 times 10 to the power of 4. Oh. A bag contains red, green, brown, and yellow marbles. The probabilities of selecting each colour are shown below. Now, we know that probability adds up to 1. So we're going to add up what we've got so far and take it away from 1 to work out what's left. So we don't know the probability of red, we don't know the probability of yellow, but it says that the probability of choosing a red marble is the same as choosing a yellow marble. So let's work out what we've got so far. So we're going to do 0.8, add 0.02, which is 0.82. And then I'm going to do 1 minus 0.82, which is 0.18. Now we know that the probability of red and the probability of yellow are the same. So I'm going to divide that by 2. They're in the ratio 1 to 1. They're the same, okay? So the probability needs to be divided by 2. 0.18 divided by 2 is 0.09. 0.09, 0.09. Find the probability then of selecting a brown or a yellow marble. So a brown or a yellow, we don't mind whether it's brown or yellow. So that means we can add those probabilities together. The probability of brown is 0.02 and the probability of yellow is 0.09. So then the probability of yellow or brown is 0.11. We're going to do those two probabilities added together. Okay, so if we don't mind if it's brown or yellow, we can add those probabilities together. Oh, I keep going to the wrong computer. Sorry. Okay, next question. When you flip a biased coin, the probability of getting a tail is 0.2. So obviously, normally we would expect a coin to be 0.5, 0.5. But when we flip a biased coin, its tail is 0.2. How many times would you expect to get tails if you flip the coin 180 times? So this is called expectation. And the expectation is going to be that if we're doing it 180 times, the number of times it's going to land on tails would be 180 multiplied by the probability of that happening. So multiplied by 0.2. Now, if you're doing 180 times 0.2, of course, it's a calculator paper, so you can just use your calculator. But to be honest, that's the same as finding 20%. So you might just find it easier to know that 18 is 10%. And so this is going to be 36 times that we expect for that to happen. So just do the number of times you're going to do it multiplied by the probability of it happening. Okay, next question. Use the graphs to solve the simultaneous equations. Now, an equation on a line essentially is just a series of points that satisfy the equation. So this line coming down here is 3y add 2,6 equals 12. Now, if you pick any point on that line, it's going to satisfy that equation. So if we pick this point, for example, this is the coordinate 6, 0. Okay, so it's got an x coordinate of 6 and a y coordinate of 0. If we substitute that into 3y add 2x equals 12, we get 3 lots of 0, which is 0, 2 lots of 6, which is 12, and that does equal 12. And that will happen for any coordinate on this line. It will satisfy this equation. Same with this line. This line is y equals x minus 1. If we pick any coordinate on that line, it will make this equation work. So let's pick this coordinate, for example, which is 7, 6. It has an x coordinate of 7 and a y coordinate of 6. So 6 equals 7, take away 1. Well, yes, it does. And every single coordinate on that line will make that equation work. We are being asked here to use the graph to solve the simultaneous equations. And then they've given us the equation of one of the lines and the equation of the other line. Now, if we want to know the value where both equations are solved, we're looking for the point that lies on both lines. So this coordinate here is on both lines. It's going to satisfy the top equation because it's on that line, and it's going to satisfy the other equation because it's on that line. So that coordinate is 3, 2. The x coordinate is 3 and the y coordinate is 2. So we're just going to say that x needs to be 3 and y needs to be 2. And if we substituted that equation, those values into both equations, it would make both equations true. And so we know that we've got a value that makes both equations solved. Okay, a train travels a total of 67 kilometers at a constant speed of 110 kilometers an hour. So immediately this question, I feel like I want to draw my speed, distance, time triangle. Speed, distance, time. There we go. How long is its journey? So it's asking me for the time. If we cover up the time, and do the sum that's left behind. We're doing distance divided by speed. So 67 divided by 110. 67 divided by 110. Is 0.609. But that's currently going to give me the time in hours. So that's currently saying that it's about 0.609 hours. Okay, so if we want that in minutes, we need to times that by 60. So if I times that by 60, I get 36.54 minutes, which is fine for the minutes. I know it's going to be 36 minutes, but I've got this annoying fraction, and I'm going to actually have to times this bit by 60 as well to work out how many seconds that is. So I'm actually going to subtract 36 from my answer. So I've currently got 36.54 occurring. I'm going to take away the 36 because I've dealt with that. And that leaves me with the 0.54 occurring. If we times that by 60, that tells us that it's actually 32.72 seconds. So that's going to be 33 to the nearest second. So 36 minutes and 33 seconds. So timesing by 60 is going to get it into minutes, and then timesing the seconds by 60 will tell you how many seconds it is as well. Cool. Just remembering that to draw your triangle speed, distance, time, distance is on the top. Every time I'm going to the wrong computer, sorry. Okay, write this fraction as a single fraction in its simplest form. Now we know that when we add fractions normally, so let's do a nice straightforward number one for you just to remind you. If we have 1/3, or let's do 2/3 actually, let's make that 2/3, add, let's do 3/8, for example. If we want to add this, we need to make the denominators the same. Now we make the denominators the same for adding and subtracting. For timesing, we just do top times top, bottom times bottom. And for dividing, we keep change flip. So because we're adding here, we want to make the denominators the same. Now the easiest thing to do to make the denominators the same is to look for a number that's in the 3 times table and the 8 times table. But obviously, when we've got algebra, that's not going to work. So we need to find a number that's in both times tables, and the easiest way to do that is to actually times them together. So if we do 3 times 8, this would need to be out of 24, or actually let's keep it as 2. Well, no, I would make it one fraction. So we're doing 3 times 8. Now if you've times this by 8 on the bottom, we need to times this by 8 on the top, so that's going to be 16. Okay, let's try that again. So because I've times the bottom by 8 to get 24, I need to times the top by 8, so that would be 16. I then need to add whatever has happened to this side. So because I've times the bottom by 3, I need to times the top by 3, so that's going to be 9. And we can then just add the tops together. So 16 add 9 is 25 over 24. And we can see that's top heavy, and we could sort that out. Now with algebraic fractions, we're going to do exactly the same thing. So we need to make the denominators the same. Now the easiest way to find the lowest common multiple of x add 1 and 3x is to times them together. So how can I write timesing this together? Well, I'm going to do 3x times x add 1. And hopefully you can see that we're going to need to use some brackets here. So I'm going to put 3x out the front, and I'm going to times it by x add 1. That's going to be my denominator. I'm timesing these together. So what have I times the left-hand fraction by? Well, I've times the bottom by 3x, so I need to times the top by 3x. So that's 5 lots of 3x. I've times the bottom by 3x. I'm timesing the top by 3x. Add, because it's an add here. What have I times the right-hand fraction by? Well, I've times it by x add 1 on the bottom, so I need to times it by x add 1 on the top. So it's going to be 2 lots of x add 1. Our next job is just to sort this all out. So the denominator can't change too much. That's going to need to stay as it is. 3x lots of x add 1. And believe it or not, it's actually simpler like that, because we might end up with some common factors with the top. So we'll leave it factorized. And then for the top, we've got 15x add 2x add 2, because I'm doing 2 lots of x and 2 lots of 1. And then bringing that together, I get 17x add 2 over 3x x add 1. Now, if both of the terms on the top were in the 3 times table, or if they both had an x, maybe we could start to cancel with the denominator. Or if it factorized and the bracket was x add 1, we could cancel with that. But as it is, there's no common factors, so that would be our answer. And that's it. So just doing exactly the same as you would do for a normal addition of fractions. We're doing the bottom numbers times together, and then the left-hand fraction has been times by the right denominator, and the right-hand fraction has been times by the left denominator. Okay, circle theorems now. A, B, C, D lie on the circumference of the circle. ADC is 99. So remember, when you're given an angle ADC, we're going from A to D to C. So we know that this one here is 99. And then BCD is 84. So BCD is 84. Now, this is a cyclic quadrilateral. And a cyclic quadrilateral is a quadrilateral within a circle, and all 4 corners, all 4 vertices of that quadrilateral have to touch the edge of the circle, the circumference of the circle. So what do we know about cyclic quadrilaterals? Well, we know that opposite angles in a cyclic quadrilateral add up to 180. So I know that the opposite angles in a cyclic quadrilateral, so the angle at B and the angle at D, and the angle at A and the angle at C, need to add up to 180. So we're now being asked for ABC, and we're being asked for DAB. So let's give both of those. We know that if the angle at C is 84, then this one is 96, because we're taking it away from 180. These two together need to make 180. And then if D, the angle at the top, is 99, this one is 81. And that's it. Opposite angles in a cyclic quadrilateral add up to make 180. Looking at our next circle theorem, A, B, and C lie on the circumference of the circle. So we've got this triangle that is touching a tangent, and the tangent is xy. Now, this is the alternate segment theorem. So if I've got my circle and I have a triangle inside it, and it's on a tangent, that's terribly drawn, then we know that this angle here is the same as this angle here, using the alternate segment theorem. Alternate segment theorem. So we know that these two are the same. We also know that this one is the same as this one. And then obviously by the nature of triangles and straight lines, we know that this one here will add with these two in the triangle to make 180, and we also know that it will add with the 2 on the straight line to make 180. So no matter what way you look at it, it's always going to add up to 180. So using that information, hopefully you can see that this angle here all the way round to the tangent is 67, using the alternate segment theorem, and this angle here all the way around to the tangent is 64, using the alternate segment theorem. Alternate segment theorem. I'll just say it again. Okay, expand and simplify. So here we have 3 brackets. Now I'm going to write this question out just a little bit nicer. It's saying this bracket times by this bracket squared. And when we square a bracket, we're saying we're timesing it by itself. So I'm going to write out 2x add 1. Oh, sorry. Come on. 2x add 1 is my first bracket, times by 3x minus 1 times by another 3x minus 1. Now, when Mr. Hegarty does this, he timeses out the second 2 brackets and then does the first one. I just do the first 2 brackets. It makes absolutely no difference to your answer. It's just the way I do it. It is entirely up to you. You are welcome to do it whatever way you want. But the first thing we're going to do is multiply 2 of the brackets together. So for me, I'm going to do the first 2 brackets. So I'm going to do 2x add 1 multiplied by 3x minus 1. Okay, so first thing we're going to do is take these first 2 brackets and expand them. So 2x times 3x. Now we need to do 2 times 3 and x times x here. So that's going to be 6x squared. Then 2x times minus 1 is minus 2x. Then 1 times 3x is 3x. And 1 times minus 1, which is minus 1. collecting your like terms together at that point. We don't want more terms than is necessary. So we're going to end up with 6x squared, add x. You can put 1x if you find it helpful, minus 1. Okay, so that is our quadratic. We've times the first two brackets together and we've got that. We now need to times it by 3x minus 1. So I'm just bringing down that third bracket and now we're timesing by that. Now I'm going to get rid of some of my working here just so I can really clearly show you what I'm going to do next. I'm going to colour code it for you. So from this, we've got 3 terms in the first thing and 2 terms in the second thing. So we're going to end up 3 times 2 with 6 terms from when we expand this out. And I'm just going to colour code them so you can see. First, we're going to do 6x squared times 3x and 6x squared times minus 1. Now, if you find it helpful, put a times on these because the most common mistake we see is people adding them, okay? We are timesing. This times this, this times this. So that's going to be my red ones. So I'll have 2 terms from that. Then I'm going to do 1x or x times 3x and x times minus 1. They're going to be my green ones. And then I'm going to do minus 1 times 3x and minus 1 times minus 1. And they're going to be my blue terms. So I'm going to end up with 6 terms here altogether. So 6x squared times 3x is 18x cubed. Then 6x squared times minus 1 is minus 6x squared. So I've done the red ones. Looking at the green ones, we've got 1x times 3x, which is 3x squared. 1x times minus 1, which is minus x. I'm just going to put minus x instead of minus 1x. And then minus 1 times 3x is minus 3x. And minus 1 times minus 1 is plus 1. So I've got 6 terms altogether that I've got to deal with, and some of them are like terms. So hopefully you can see that the 18x squared needs to stay on its own. There's no other like terms. There's no other terms that are x cubed. We've then got these two, which are both x squared. So minus 6x squared add 3x squared is minus 3x squared overall. I've then got these two, which are both x terms, minus 4x. And then I've got the plus 1. And that would be my final answer. 18x cubed minus 3x squared minus 4x, add 1. Okay, find the lowest common multiple of 98 and 182. Now, to find the lowest common multiple, normally we do the tree diagram, the tree thing, the prime factorization for both. So 98 is 49 times 2, 2 is prime, so circle it. 49 is 7 times 7, so let's circle both of those because they are both prime. And then 182 is 91 times 2. 91 is, I feel like it's 7 times 13. Yeah, let me just check. Doubt myself. Yes, 91. The beauty of having a calculator for this paper. And they're both prime. We then do the Venn diagram for 98 and for 182. And then we know what's in common goes in the middle. So they've both got 2 and they've both got 7. The 98 has a 7 left over and the 182 has a 13 left over. If I want the highest common factor, the biggest number that fits into both, I would do 2 times 7. All the numbers in the middle times together, which is 14. If I want the lowest common multiple, I'm going to take that 14, and times it by what's left on the outside. So times it by 7 and times it by 13. So all of the numbers timesing together, 14 times 7 times 13 from within the Venn diagram, which is 1,274. Done. Cool. So tree diagram, put it in a Venn diagram. What's in the middle is the highest common factor. We were asked for the lowest common multiple. So we take that answer and times it by what's left on the outside. Okay, a bounds question now. And the reason we know it's a bounds question is because it says 370 has been rounded to the nearest 10 and 3.7 has been rounded to the nearest 1 decimal place. So when a number has already been rounded, we need to take into consideration what the biggest and the smallest it could have been before we rounded it or before someone else rounded it. So if we've rounded to the nearest 10, it's going to be 5 above and 5 below. Now, I like to take the question and just say, right, that could be 375 as the upper bound and 365 as the lowest bound. And then with B, it's 3.7 rounded to 1 decimal place. So that's going to be 3.75 as the upper bound and 3.65 as the lower bound. It's been rounded to the nearest 0.1. So that's 0.05 above and 0.05 below. You're always halving what you've rounded to. So we then want to find the minimum of A times B. Now, the minimum for a multiplication is going to be the smallest A multiplied by the smallest B. So 3.65 times 365. That's the smallest B and the smallest A being multiplied together. We can then use our calculator, 3.65 times 365. And that is 1,332.25. Now, if you were doing a division and you wanted the smallest answer, you would do the smallest numerator and you'd share it between as many people as you can. So you do small divided by big. If you wanted the biggest, you would do big divided by small. But if you're ever in doubt, try the different numbers that you've got and see what the biggest and the smallest you can come up with is. Okay, AB is 4.3. Let's label that on. AB is 4. Oh, sorry, pen would help. AB is 4.3. BC is 3.6. And CG is 6.2. We would like to know DF. Oh, no, it's not going to let me do it in a colour. DF rounded to 1 decimal place. Now, to get DF, it's obviously going diagonally across the cuboid. We need to make a right-angled triangle using that. We really should do some different colours. Sorry. Oh, that's far too thick. Let's use blue. Oh, that'll do. So this is a right-angled triangle because we would get a right angle here. Okay, and that's going to enable us to get this side using Pythagoras. But to be able to do that, we know that this side is 6.2, but we'd need the side on the floor. So I'm going to make another triangle on the floor here. And we know that that is also a right-angled triangle because it's the corner of the cuboid. So we know that we've got for the floor, for the one that's on the base, we're going to use Pythagoras, and we're going to do 4.3 squared, add 3.6 squared, and then square root our answer. I know that this side here is 3.6. So we're just doing Pythagoras just in 3D, so it's just on the floor of the shape. So using my calculator, I've got 4.3 squared, add 3.6 squared. And I'm going to square root my answer, and I get 5.6080. That. And I'm just going to write out quite a lot of the digits because I don't want to round it too soon. We're then going to use that. We now know that this is 5.608 here. That's the hypotenuse of this one. And we're going to use that and the fact that we know that the height here is 6.2 to get the hypotenuse of this next triangle. So I'm going to use the value I've just got in my calculator. I'm just going to use that and square it straight away. So I'm not going to have to type it all out again. I'm just going to keep it really accurate. So that squared, add 6.2 squared is 69.89. And again, we're going to square root that answer, which is 8.36. So 5.608 squared, add 6.2 squared, all square rooted is 8.3600239. So I'm fairly happy that that's, oh, I didn't want to write that next to it apparently, 8.3600239, and that's it. That's all we want, D to F. So rounding that to 1 decimal place would be 8.4 centimeters. Don't forget the units. Wonderful. So you're just making right angled triangles inside the shape and taking what you know to get the diagonal. You must form right angled triangles though. You can't just make a triangle and try and find it. Use right angled triangles, particularly in a cuboid. Okay, the graph shows the speed in meters per second of a car. Select the option below which best oh, so I've copied this off Hegarty, so we're not going to select the option, we're going to do it. We want the distance travelled by the car during 10 seconds. Now we've got speed on the y-axis and time on the x-axis, and we want the distance. Now remember from our triangle that speed, distance, time, if I want the distance, it's speed multiplied by time. So to get distance, I have to multiply the speed and the time together. Well, what would that mean on the graph? On the graph, I've got speed on the y-axis, time on the x-axis. Timesing them together would be the area. So actually what we're looking for in this question is the area underneath the graph. Now, we currently don't know how to work out the area under a curve, okay? But what we can do is estimate, okay? What we can do is estimate. Oh, let me just undo that. So we're going to estimate by splitting this up into sections. So I'm going to make a triangle here. And I feel like 5 sections is a good thing to do. I've got 2, 4, 6, 8, 10s. It makes sense just to split it up like this. I'm going to make another section here. It's going to be a trapezium. Another section here. That's going to be another trapezium. Another section here. And then this last one actually is probably going to be a rectangle because we've got the same value for the start and the end. Now there is something called the trapezium rule, and there is a formula for doing this efficiently, and please, if you want to, look that up. I'm actually going to treat it as 5 different areas just to really show you what's happening, but if you want to use the trapezium rule, please look that up and see. So for this triangle, we know that a triangle is base times height divided by 2. So that's going to be 2 for the base times by the height. Now we can see that if the 5 squares make 10, it's going up by 2 every time. So this is 22. So it's going to be 2 times 22 divided by 2, which is 22 for the first section. And now we've got 3 trapeziums. Now the area of a trapezium, if I do it this way, is A add B divided by 2 times by the height. Now hopefully you can see that all of these are on their side. So A and B are going to be my 2 different heights, and then the height is going to be the width, if that makes sense. So A add B is 22 add 30 divided by 2 times by the height, which is going to be how wide it is, which is 2. Okay, so we've got 52 divided by 2 times by 2. So it's just going to be 52 for that bit. For this bit, same thing. I've got A add B. I've drawn that triangle terribly, but hopefully you can see it's 30 add 34 divided by 2. We always divide by 2 for a trapezium. And then times that by how tall it is, which is 2. So that's going to be 64 in total. The next bit is going to be 34 add 36 divided by 2 times by the height, which again is still 2. So those cancel out and we've still got 70 there. And the last one's just a rectangle, so base times height, because this and this are the same. So when we add them together and divide by 2, we're just going to get that value. So 36 times by 2, which is 72. So the distance travelled is going to be all of those numbers added together. So we're going to do 22, add 52, add 64, add 70, add 72, which is 280, and that's going to be meters. The reason we know it's meters is because the speed is in meters per second and the time is in seconds. So it makes sense that the distance travelled is going to be in meters. And I think that's it. So going back to the beginning, back to our revision list, which for some reason is on the second page. That is all of the ones there. Now, some of them obviously are together. So 3D Pythagoras also has the bounds question as part of it, and so on. And you've got algebraic fractions with quadratics. But don't forget, all of your Hegarty numbers are here. So if there's anything I went over that you're not sure on, go and watch the Hegarty video specifically for that one before the assessment tomorrow. Good luck, and yeah, I hope it goes well. Thank you for listening.